Dum dum dum. Today we are doing Pythagorean theorem. It is very scary to kids. It should not be. I'm not going to tell you it's going to be super easy, but you guys have a calculator, so it should be not that difficult. It's going to involve you doing some square roots, and I don't have a square root calculator here, so it's going to kind of suck for me a little bit because all I have is my cell phone calculator. So, and it doesn't do square roots. Not really sure why. It'll do cube roots and whatever I want it to do, but it won't just do a specific square root. All right, so make sure you have a calculator. You're probably going to want some scratch paper, and let's get started. Okay, guys, so before we start, we really need to understand what is the Pythagorean theorem. And Pythagoras figured this out. He figured if you have a triangle, this is your hypotenuse. So you always got to know the hypotenuse is the longest side, okay? So he figured out that if you take this measurement of this side and this measurement of this side and you square both of them, then add them together, it will give you c squared. So a squared plus b squared is going to give you c squared, okay? All right, so this should be super easy today. So we're going to go and start doing some examples with numbers. Okay, guys, so we have this triangle now. We have that this side measures 8 feet. This side measures 10 feet. We need to figure out what this side is measuring, okay? But we know that a squared plus b squared will be c squared, okay? So we're going to plug in 8 for a, because this is our 8, this is our b. 8 squared plus b squared will equal 10 squared. All right, so we know 8 squared is 64. So 64 plus b squared, we don't know. And we know that 10 squared is 100. Sorry, guys, I always do that. Okay, so I'm going to subtract 64 on this side because we want to get b squared by itself. So 64 minus 64 is nothing. And 64 minus 100 is 36. So b squared equals 36. Now, let me get this. Okay, guys, let me go over here. So we have b squared is equal, to 36, okay? Because I'm running out of room. All right, so we have to get rid of the square because we want b, the variable, by itself. And the only way to get rid of a square is to square root it. So if I square root this, it's going to give me b. And if I square root this, it's going to give me 6, okay? So b is equal to 6, okay? Square root of 36 is 6. Now that one was easy because I could do that in my head. All right, guys, we'll do a couple more. All right, guys, so I do have my calculator for this one because these are some pretty big numbers. And I'm actually going to start over here so I don't run out of room. All right, so we know a squared plus b squared equals c squared. Also, I don't know if I mentioned this, but Pythagorean theorem only works in right triangles, okay? Only in right triangles. It's not going to work on a equilateral triangle, but if you think about it, an equilateral triangle doesn't have a hypotenuse because all the sides are equivalent. So, wouldn't work on that. All right, so I'm going to start with my a squared plus b squared equals c squared. Okay, sorry, I'm trying to do this in a sloped back chair. It's not holding up right. Okay, so a squared is what we're looking for. We're looking just for a. B is 24 squared, and c is 26 squared. What I want y'all guys to do is I want you to pause this right now and try to work this out on your own and see if you get the right answer, okay? So pause and see if you get the right answer. Okay, so I'm using my calculator. So I have a squared plus, I'm going to do 24 times 24, and I get 576. And then 26 times 26 is 676. All right, so I'm going to, I have to get rid of this. So I'm going to subtract 576 here and 576 here. This cancels out. So we have a squared, and this is just 100. All right, now, again, I can do this one in my head. I'm going to take the square root of this, and since I do it on the left, I got to do it on the right. So a is equal to 10. Okay? And you could also, you could check this out to see if, well, no, you couldn't. I'm sorry. But anyway, here we go. All right, guys.